Hello guys, once again, we're back with another Call of Duty Killstreak tutorial. Today we're taking a look at Rolling Thunder. Drones that spawn, fly and just mash stuff down the battlefield. Boom, 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 boom. Now, of course it's dynamic, you know me, I make dynamic stuff. Also there are some hard-coded values, so let's get into it. This thing again is a simple bomb site, just a placeholder so you can see. It's nothing hard coded. I just use these values. So, couple things. These stuff that fly are the Rolling Thunder drones. Are these crap, and we don't actually need that sphere anymore. So, and we got a spawner, and of course we got our first person character. Now, it's not that simple to spawn it. You just specify a transform and it gets spawned. Now, why transform and not a target location? Because Rolling Thunder has got rotation stuff, so if I set this to 0, it would be from the other side. It would be from there, and it will go that way. And if I set this to, let's say, something like 45, it will be diagonal, so it will be like that. This thing is the first location to bomb, and then it's like carpet bombing the same direction. So you just specify the transform. You can change that in the killstreak picker or whatever you want. So let's get into it. The spawner consists of two parts, all triggered on the begin play. First things first, the variables we're going to use. The target transform is the first transform we're going to use. It's a double explode and spawn, and then there are the spawn transform, which is calculated based on the target transform, the spawn location offset, and the fall down offset. There's a gap, as you can see, when you spawn them. There's a gap. This gap is actually the spawn location offset, so it goes incrementing from 0 to 1 and 2 and 3 times this vector, so you can spawn them in succession. Then it's the fall down offset, which is how far does the drone need to be from the target when it starts going down. So take a look at what happens. It's there. If I change this to something, let's say, where is it? Something like 5,000. It will go more back. It will start going down from previous location. So I think 7,000 is a good one. Maybe 6,000, maybe 600 and something more. So now that you know what each thing does, let me explain what the drones do, and I'll come back onto the spawner in a second. So once again, we got my infamous almost equal vector node, this time with an error tolerance of 1000, because shit happens when you lerp vectors and it's not accurate. And that basic tree, so these interp2 are not happening with a constant rate, so we don't want the drones to slow down, speed up by time, so we don't use them. We just use interp2 constant, and you can mess around with interpolation speed. It's how fast they move. So first branch, if you've got my other tutorials, you'll know that first state is to fly to the target fall down point. When you approximately reach that point, the state changes and the second part of the code triggers, which moves the actor to the explosion point. with a sweep, of course. And now there's a bug when you spawn stuff dynamically and want physical based collision stuff, so we do a line trace by the visibility channel on the down vector, getting the up 1 meter down. We inverse it because it's the minus there, and just basic line trace. And if it hits something, you can of course check what it hit and stuff. We can explode there and then destroy the actor because it exploded and it's dead. So the spawner spawns however how many drones you want. I've done 7 here or 6 or whatever. You can change it, you can add multiple rows and stuff, and it only provides the fall down point, the explode point, and the transform. Now these are calculated based on these variables we have. So for example, the fall down point and the spawn transfer have a constant z of 2000, which I think is a good height, and the scale is 1. So the explode point has z of 210. You can set relative to your ground level, maybe something lower, so it goes down enough, it explodes. Let's go back to this calculation. Well, we need to get the drone's forward vector, and we do that by getting the rotation from the transform, from the target transform. So it's just basic vector math. The spawn transform is a vector rotated from the target transform, and then it's going back. So if that's a vector, it's going to rotate and the plane is going to spawn back there. They're going to go forward. It's basic vector math. I'll just let you take a peek. The first branch location, add the forward vector, ignoring the z values, yada yada yada, and you set the spawn transform. Then same thing with the forward vector. A smaller inverse one is the location offset, so it's you're not it's the other side actually. And then the fold down offset is like a shorter spawn vector, which is going to be compared afterwards. So now this part's a little tricky. You get the index, which is how many drones you've spawned, and you basically add stuff. You basically compose these values based on the index and these. So the more drones you spawn, the further they're going to go back. So more location offset, more spawn location offset is going to be added to the spawn transform. So you multiply this and add them together with this node, and there you have it. Same thing with the fold down offset, as you can see, but you also need to double the location offset, because you're going back when you spawn, and then you need to go double amount forward, so you got the same feel for everything. Take a good look at it. I can't explain everything in this video. It's kind of hard to explain basic concepts. And then the target transform, moving forward on each pass, on each spawn pass, so it's like a carpet bombing. Of course you can change values, of course you can make it dynamic. There you go. So you can see it's added more and more and more. I hope I helped you understand how this stuff are done in this tutorial. It's kind of hard coded, but you can change it. You can have 2 rows if you want to, like the Black Ops 3. And see you next time. And thanks for watching.